Okay, so let's talk through a few questions about standard deviation and normal distributions. So we're going to answer the following questions about standard deviation and normal distribution of data, and we are going to round to the hundredths place if we need to. So first question, find the standard deviation of these 6 numbers. So we start by taking the average of those numbers. So I'm going to add them together. Okay, and all together it totals $918.02, and there are 6 values, so I'm going to divide that by 6. And I get an average of 153.00. Okay, it's going to round to 153.00. Now, because I'm rounding to 2 decimal places each step of the way, my answer is not going to be precise. It's going to be a little bit of an estimate. But as long as we're all rounding to the hundredths place, we should get similar answers as we go along. So we're using 153. Alright, so first thing we needed to do, if we go through the steps from the notes, is we need to find the distance each value is from the average. So I have 146.01 minus 153. I get negative 6.99. And then I do 163.20 minus 153, and I get a value of 10.20. Then I'm going to take 157.36, and I'm going to subtract that 153, and I get 4.36. Okay, then I'm going to do 148.97 minus 153, and I get negative 4.03. And then 160.84 minus 153, and I get 7.84. 141.64 minus 153, and I get negative 11.36. Okay, next step is to square each of those values. So if I square this, I get 48.8601. If I square this, I get 104.04. If I square this, I get 19.0096. And I know we talked about rounding the hundredths place. Since this only has 4 values and it's not a continuing decimal, I am going to keep those 4 decimal points until I get to the end. So I'm going to take this and square it, and I get 16.2409. I'm going to square this to get 61.4656. I'm going to square this, and I'm going to get 129.0496. Okay. Now, I'm going to go ahead and add all of these together. So take a minute on your calculator and do that. You can pause the video if you need to. I total that to get 378.6658. And again, there are 6 values, so I'm going to divide that by 6. And I get 63.11. Okay, then I have to take the square root of that 63.11, and my final answer is going to be 7.94. So my standard deviation is equal to 7.94 in this case, or roughly 7.94. Okay, all right. So that's standard deviation. Second question. We have an ACT composite score for the school is 15. The average is 15, and so these scores are normally distributed. Typo, I'll fix that. The scores are normally distributed with a standard deviation of 2, and we are asked to find the percentage of students whose score is at least 13%. So the average goes here in the middle. That's 15%, or 15 score, and the standard deviation is 2. So if I go positive 2 to the right, so 15 plus 2, I get 17. Plus another 2 is 19, and plus another 2 is 21. If I subtract 2, I get 13. If I subtract 2, I get 11. If I subtract 2, I get 9. So this is the breakup of the scores. Okay, so that means this is again 34%, this is 34%, this is 13.5%, and 2.35. This is 13.5, and 2.35. And then of course that 0.15% way out here. So what this means here in this question is that 34% of the students will score between a 15 and 17 if it's normally distributed, which our question tells us that it is normally distributed. 13.5% will score between a 17 and 19, 2.35 will score between a 19 and 21, and 0.15% of them will score above a 21. Okay, same thing in the other direction. 34% of them will score between a 13 and a 15. 13.5 of them will score between 11 and 13. 2.35 of them will score between a 9 and 11, and 0.15 of them will score below a 9 on their ACT composite score. Okay, so the question is, find the percentage of students whose score is at least at 13. So that means from 13 on, okay, at least at 13. So that's going to be 34% plus 34% plus 13.5% plus 2.35% plus 0.15%. And so that totals 84%. So if the data is truly normally distributed, then 84% of the students should have at least a 13 on their ACT composite score based on this data that we've been given. Okay, now here's another question. The average height of the girls on a high school basketball team is 64 inches. So average height, 64. Okay, that's going to be our middle number here. Their heights are normally distributed. Okay, that's important. Normally distributed tells us it's a bell curve with a standard deviation of 1.5 inches. So 64, I'm going to be increasing. So 65.5, and then 67, and then 68.5. And then going the other direction, it's going to be 62.5, 61, and 59.5. Okay. So what percentage of girls are between 5 foot 1 inch and 5 foot 5.5 inches tall? Right. So here we have 65.5, 67, 68.5. Okay, each of these represents a percentage. So we have 0.15%, 2.35, 13.5, 34, another 34, 13.5, 2.35, and 0.15. Okay, now the question is a little interesting because we're talking about inches, and then we split to 5 foot 1 inch and 5 foot 5.5 inches. So we do need to do a quick conversion. So let's start with how many inches are in a foot, and let's convert these into inches. So 12 inches in a foot, so 12 times 5 plus that 1 inch is going to be 61 inches. Okay, then we have another 12 times 5 for those 5 feet plus another 5.5 inches. So 60 and 5.5 is going to be 65.5. So the question is, what percentage of girls are between 61 inches, that's here, and 65.5 inches, that's here. So that's going to be 13.5 plus 34 plus 34, which totals 81.5. So again, the data shows us that 81.5% of these girls are going to fall between 5 foot 1 inches and 5 foot 5.5 inches tall based on this normally distributed value that we have.